All right, so I posted your first assignment, and so if you go to Blackboard, and I'm looking at the student view, and just on the main page of the student view, we have the agenda. Let's just look at the agenda just a minute. Well, it seems to be slow today, doesn't it? Okay, so here's the agenda, and so here is the 31st of January here. So what are we going to do this week? This week, I'm going to talk about hardware, which is CO2. That means it's going to be the CO2 set of PowerPoint slides, which are available on Blackboard. It also means Chapter 2 in the textbook. That would be on hardware. I'm also going to talk about I01, which is an issue, and it's a chapter I01, and also the PowerPoint slides I01 on it. Assignment 1 is due next week, okay? On the week of 2/7. All assignments are due when? All assignments must be submitted via Blackboard, okay? All assignments are due Saturday midnight of the week listed, okay? All assignments are due Saturday midnight of the week listed, which means this assignment, A1, will be due on the Saturday of the week of 2/7, okay? At midnight. And it can't be late. We don't accept late assignments, okay? Unless, you come to me and give me an excuse, okay? And then what happens if I accept your excuse? What happens if you miss a quiz or an assignment? So if you turn in your assignment late, we won't accept it, okay? Blackboard is set so that the assignment's cut off at that time. You try to submit it late, but it won't take it, yeah? And so what happens? You get a 0. And then you can come up to me with an excuse. If I accept your excuse, what happens? What happens if you miss a quiz? If you miss a quiz, you get a 0, okay? Unless I accept your excuse. And what happens then? Yeah, you don't get a makeup quiz, okay? What happens? Well, if you miss a quiz, you get the value of the lowest quiz, okay, grade of the ones you do take, okay. But I only accept one miss. If you miss 2, that's too bad. Okay, you still get a 0 on the second one. Okay, so what is the assignment then? Okay, and So you have to look over here, and we have here announcements, we have assessments, and we have assignments. So we click on assignment, and we see there is assignment 1, okay? And so we can click on assignment 1. And what we see is that there are 3 documents available on assignment 1, okay? There's one document, a PDF document. What does PDF stand for? What does PDF stand for? Anybody know? PDF, what does it stand for? It stands for Portable Document Format, okay? PDF, Portable Document Format. And it's a format that was, I guess, invented and decided upon by a company called Adobe. Okay. So anyway, what do you know about the PDF format? Well, in order to read it, you got to have the Adobe Acrobat Reader, right? And so you have to download the Adobe Acrobat Reader to your computer. These computers you have here, they should all be there. So anyway, there's that one document there. Then there's 2 docx's, okay? What's a docx document? It's a Word document, right? What's the difference between doc and docx? They're both document formats. Docx is an extended document format, and to read a docx format, you have to have at least Microsoft Office 2007. And if all you have is 2003, you don't have. They won't read a docx. So here's the assignment itself, and then there's something else called assignment 1 template evaluation criteria. So let's click on assignment 1 and see what it says. So assignment 1, companies in the computing industry. Use the internet to research important aspects of a company in the computer industry. The last digit of your PeopleSoft ID determines your specific topic. So there's 10 topics, okay? 10 different companies that are in the computer business. One form of the computer business or the other. So IBM, Microsoft, Intel, Google, so forth. So if your last digit of your PeopleSoft ID ends in a 7, okay? You have to write this paper about Dell. If it ends in an 8, BMC. Yeah. Write a university-style research paper on this company in MLA format. Now, what is MLA format? Well, we're going to see what it is. It actually stands for the Modern Language Association. There are different formats for research papers, and different disciplines have different formats. Okay? But this is a widely used one, okay? And people in the modern languages, okay, you have to use this particular format. Using the accompanying stencil, so in addition to having the MLA format, I'm going to have a stencil for you to follow. Your report should be about 4 pages, double space, plus single space references. Now, I want some references, okay? This is a research paper, so there should be references. Limit your report to those aspects of the company that you deem most interesting. That is, you're not supposed to write a report about, say, if your company is Microsoft, you're not supposed to write a universal report about Microsoft. It's only got 4 pages. You're supposed to pick something about Microsoft that you think is interesting. And it can be anything that you think is interesting about Microsoft. So what you think is interesting might be different from what someone else writing about Microsoft thinks is interesting. Okay? And it could be anything. It could be something about Bill Gates, okay? It could be something about Melinda Gates, okay? It could be something about how Microsoft got started. It can be something about the government suing Microsoft. It can be something about how Microsoft was a bad company, you know, in the computer, you know, trying to trounce all the other little guys, right? And so you pick something that's interesting about it, okay? So limit your report to those aspects, or an aspect. Doesn't, you know, I said those aspects, but it can just be one aspect, okay, of the company you deem most interesting. These may be company history, company products, unique aspects of the company, success or failure of the company, critical obstacles that the company had to overcome, a crisis that the company had to face, people in the company, or any other interesting aspect. Submit your report via Blackboard, okay, and the date to do is February the 11th, okay, at 11:59 p.m. Okay, so that's assignment number 1, okay? Now, let's see, the next thing I want to look at is this other DocX 1300 S12 assignment 1 template evaluation on criteria. So here is a template, okay, that is, you know, you can, it basically, this template has in it what it should look like. So your name goes here, okay, my name goes here, you know, computer science 1300 goes here, the date. So basically you can just, you know, start with that and then just erase this stuff and put in what you want, okay. It shows you how to, it shows you the type of font. Okay, this uses Courier New, and it's double spaced. Okay, shows you how to indent. Okay, it shows you what to do on a block quote. Okay, there's a block quote, how to indent it. Here is the works cited, okay. And those works cited should be cited, okay. And here's how we're going to grade it, okay. If you do everything right, you'll get 100 points. Okay, we're going to look at the format of the thing to see if the format's right. We're going to see if you have your citations in here. If the citations are actually cited, okay. We're going to look at the grammar, the punctuation, spelling. That's 20 points. We're going to see if your thing is clear and logical. Okay. What we don't like is things that kind of ramble around and don't get anywhere. What we don't like is really long sentences. Long sentences are usually hard to understand and usually not well written. We want to know, does it answer the question that if you're looking at a particular aspect of the company, what is it? Okay, so that then gives you something to start with. And then the last thing I'll look at is this MDA format, PDF format. And this I copied this off of the internet from Cal State, okay. And so it goes to the formatting basics, okay. And you can read all of that, okay? It gives you a sample first page. And this little stencil I gave you should follow that. Okay? And you should read this, okay? And then it tells you how to make citations, okay? Gives you examples of citations, okay? Okay. So you got these three documents then, okay? And so any question about that? No questions, okay. So have you heard of all these companies? I mean, you may have a company that you haven't heard of. Okay, have you heard of BMC? Yeah. Lenovo. What's in the Lenovo? Yeah.
I was wondering, was it like 4-page writing and then the work site, or the work site page counts more for?
It counts. I don't expect you're going to have that many citations. Okay, a few. Okay. Yeah. No, you have to do the company that you're assigned.
What if your last one's 0?
If the last one is what?
If your last digit is 0.
Yeah, 0. It would be Amazon, right? I guess that should be a 0 there, not a 10. You know, you try to find something. Here's something that's interesting about Microsoft is Melinda Gates, Bill Gates' wife. You know, you can research Melinda Gates. Melinda Gates is a really interesting story, I think. You know, you write the whole thing on her. Actually, they had a big article on Melinda Gates in Fortune about a year ago called "The $1 Billion Woman." Anybody here know anything about Melinda Gates? She was from Dallas. Did you know that? Her name was Melinda French, and her father was an engineer. Worked in Dallas at Ling Temco Vault. It's a company that up there made airplanes, and she was a nerd. Her dad bought her an Apple computer, an Apple II computer when they came out. And she loved this little Apple computer. And she learned to program it in BASIC. And taught her girlfriends to program this little Apple computer. And so decided that she wanted to go to college and major in computer science. And so she went to Ursuline Academy in Dallas, a private school. Now, they were Catholic, so Ursuline Academy is a Catholic school. So she went to this Catholic girls' school. And after she finished Ursuline Academy, she decided that she wanted to go to Notre Dame. She was a Catholic. So the whole family went up to Notre Dame, you know, to check the school out. And she was going to go to Notre Dame and major in computer science. And they told her in Notre Dame that they were not emphasizing computer science. They didn't think it was here to stay. And so they suggested if she came to Notre Dame, she should major in something else. So she decided she didn't want to go to Notre Dame. So instead, she went to Duke University, and up on the East Coast, and majored in computer science, and also had a double major. She majored in computer science and she majored in economics. And she stayed at Duke University and got a master's degree. business administration. And then she went to work for Microsoft. She said she had offers from IBM and she had offers from Microsoft, and she said the lady at IBM advised her to go to work for Microsoft. So she did, and she had a very good career at Microsoft. She became a manager, and of course then she met Bill Gates. And she said the first time that she met Bill Gates was in New York City. She was there on a convention, and Microsoft had a booth, and she was managing, one of the people in the booth. And they had a dinner, a Microsoft dinner, and so Bill Gates came and joined them at this Microsoft dinner, and she thought he was very funny. Anyway, she said that one day she was in the parking lot getting ready to come home, and she met him in the parking lot, and he asked her for a date. And he said, would you go out with me 2 weeks from Friday? And she said, well, 2 weeks from Friday. He says, well, why don't you ask me when it gets a little closer? And he did. He waited until that day, And they went out, and then so she starts going with the boss. And so she's in a kind of a ticklish situation, right? Going with the boss, right? And so she's determined she doesn't want to ask him for any favors. See? I mean, given her new position, and she didn't want to. And he complained. Well, he says, you never tell me what you're working on, see? But anyway, she's able to try to keep this dating the boss separate from her work. Anyway, so finally he pops the question. They get on the company plane to go down for her to meet his parents. So they fly all the way across the country, from Seattle down to Florida, where Bill Gates' parents are, so she can meet the parents. And that's always a little nerve-wracking, right, to meet the parents. Anyway, it goes good, and on the way back, the plane stops in Omaha. And who gets on the plane but Warren Buffett? Who's Warren Buffett? Anybody know Warren Buffett? It's like the second richest man in the world, right? Bill Gates, the richest, and Warren Buffett, maybe not now. I don't know the latest ranking, right? But anyway, and Bill Gates and Warren Buffett are good friends. They play bridge together. So they get in this limousine and they go across Omaha to this jewelry store. It happens that Warren Buffett owns a jewelry store in Omaha. So they're going to buy her ring right there on the spot from Warren Buffett's jewelry store. And Warren Buffett says to her, he says, well, Melinda, he said, when I got married and I bought my wife her ring, he said, I spent 3% of my gross net worth for her ring. He said, I'm sure Bill will want to do at least that much. So he's worth about what, $50 billion. So 3% is, a ring would be a $1.5 billion ring. Big, heavy. And anyway, they got married in Hawaii. It was a small ceremony. Her favorite singer was Willie Nelson. And Bill had Willie Nelson come out, and sing. They got back to Seattle, and he was building this huge home on Lake Washington. She said that home was a bachelor's dream and a new bride's worst nightmare. And so they had to redo the entire home, for her. Had to re-architect it and everything. So anyway, it's been a very successful marriage. There was no pre-nuptial agreement. And they got 3 kids now, and have this big, so that'd make an interesting story. So you can do that in 4 pages, right? And that's the kind of thing I'm looking for. Something unusual, something different, about these companies. Okay, so any question about that? Yes.
How do you know so much about them?
I read that article in Fortune magazine. It's about a year ago. You go look up at the Fortune magazine about a year ago. It's on Melinda Gates, the $1 billion woman. It was the first article actually written about her, and she was actually kind of a mystery person, you know, to the people at large until that Fortune magazine came out. And it's got a lot of good pictures there too. Okay, so now, how many of you have actually brought up the book? Okay, so what you do is you go down to where it says SCORM. You click on SCORM, and then this should come up here, and then you click on that, and then this should come up. Okay, and so this is the title of the book, Emerge with Computers here. And so then you should go down to this 1.1 and click on that. And then this should come up, and this is the textbook. This is the online textbook, okay? And it'll have all the stuff in it that's in the little printed textbook if you have the printed textbook. But it'll have other stuff too. And over here is the contents, so you can say expand all. And this gives you the contents, okay? So here's the first chapter is digital technology, and you can click on that. And this is digital technology, okay? And you can read it, and it'll have all the stuff in it that's in the printed book, but it also has other stuff too, okay? It has these little videos here. Here's one on the weirdest, wackiest products, okay? And so it's this couple they're at this trade show, you know, showing off the newest electronic gadgets. Then there are self-quizzes in all of these sections here. Representing all types of information, blank, allows that information to be stored, transported, and manipulated in ways previously not possible. What's the answer to that? Digitally. So anyway, you can take these self-quizzes, okay? They're not required. These are just to help you, particularly when you're getting ready for a quiz, okay? So anyway, that's the textbook. Now, I'm going to close this out now, and I'm going to go over to the PowerPoint. So last time I was talking about digital technology. And I talked about bits and bytes, I talked about ASCII, binary number system, and digital convergence. Okay. Alrighty. So, Kenneth Oliver. Kenneth, are you here? Hello? Not here. You know, when you're not here and I call you, you get a 0. Lauren Orda. How you doing? Lauren, what is meant by digital convergence? A little louder.
Did you say digital conversion or digital convergence?
Digital convergence.
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 It says several digital electronic devices in
No.
I said it takes several digital electronic devices into one.
No.
It's smaller and faster.
No. Okay. Let me try somebody else. Okay. Tracy Palos. Tracy, are you here? Tracy. Hello. Not here? 0. Okay, Nicole Paula. What is it, Nicola? What is digital convergence?
It takes like it takes data and then like it puts data into like one system. It just puts data into like a binary system and then it creates devices that can function in different ways.
Not exactly. That's sort of right. I'll give you a half on that. Okay, Yun Ro. Yeah, what is it?
Isn't there like changes in the computer technology, like the how they store and then how they produce like videos and then pictures?
Well, sort of. Digital convergence is, what it means is, you can store everything, okay, in zeros and ones, okay. You can store numbers with zeros and ones. You can store text with zeros and ones. You can store pictures with zeros and ones. You can store sound with zeros and ones. You can store movies with zeros and ones. Everything converges to zeros and ones. And what it means is you can have one device that can store all those things. Okay? You don't have to have different devices, okay, for text and numbers and pictures, okay. One device, okay. A computer, a smartphone, okay, can store all these different things digitally with zeros and ones, okay. Okay, so you want to ask me that, how do you store text digitally? Text.
In the binary numbers?
No. No, you store numbers, binary numbers. That's not how you store text, okay? How do you store text? No. Okay. No. Ryan Sabu.
You use, is it like 16, 32, the hexagonal
No. That's again how you do. You want to volunteer? On the second row there. What's your name? Howell. Have you already answered something? Yeah. Okay, that's all right. Go ahead, answer it. That's what I'm looking for. Exactly what I'm looking for. ASCII. The word what I want you to say was ASCII. How do you store text? You use ASCII. Okay. What's ASCII? Right. That's good. Okay. Now, If I wanted to know how to store something in ASCII, how would I find out? Yeah.
Wouldn't you look up the ASCII chart table thing?
Yes, exactly. Let's do that. So if I wanted to know how to store something in ASCII, I would Google it, right? It's a wonderful word. Google it. You would put in ASCII, okay? ASCII. Okay. Do you have to put it in capital or little letters or what? You know, on these engines, like Google, the search engines, usually don't care where you put it in capitals or small. So here's ASCII table here. Well, this thing looks complicated. How do I read this booger? Anyhow, how does this tell me how things are stored in ASCII? Okay. Let's take a left parenthesis. No, let's take a right parenthesis right here. Here, whoops. Here's a right parenthesis, okay? And it's got a right parenthesis there. I can see this right parenthesis, okay? But then it's got a bunch of stuff over here. 41, 29, 051, ampersand, pound sign, 41. What in the world is all of that stuff? So a right parenthesis has got a 41 here. And then that's decimal. So it's up at the top, it says dec, okay? This line up here says dec, it says 41. Then it says HX, okay? 29. And then it says OCT, OCT, 051. And then it says HTML. Ampersand. So this is a right parenthesis, okay? Oh, sorry. Where you went to me? right parenthesis, okay? That's what this chart says, okay? On the right parenthesis, it says 41, 29, 051, ampersand 41, semicolon, right parenthesis, okay? That's what it says, okay? What does that mean? What does all that stuff mean?
All the same thing.
What?
They're all equal.
Yeah, so the HX means in the hexadecimal number system. Okay? And that is right parenthesis in the hexadecimal number system is a 29. What in the world does that mean? Hexadecimal means base 16, right? 051 in the octal number system. What does that mean? It means to the base 8. So in the decimal number system, it means 4 times 10 plus 1. Yeah? That's 41. In the hexadecimal number system, it means 2 times 16 plus 9. Yeah? In the octal number system, it means 0 times 64, and that's 8 squared, plus 5 times 8, okay, plus 1. Okay? Well, if you add all those up, okay, they all come out to be 41, right? And HTML, okay, is also 41, okay? But what's important is the thing, this right parenthesis is actually stored in binary. How does this tell you how it's stored in binary? Well, hexadecimal is a shorthand binary. Octal is also a shorthand binary. See, since hexadecimal is to the base 16, 16 is 2 to the 4th power. So 9 to the base 16, okay? You can change this into binary by converting each hexadecimal digit into 4 binary digits, okay? So hexadecimal has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Okay? A 0 in hexadecimal is 4 binary zeros. See? A 1 is 0, 0, 0, 1. A 2 is 0, 0, 1, 0. A 3 is 0, 0, 1, 1. A 4 is 0, 1, 0, 0. 5 is this, okay, and so forth, okay? So 2 is 0, 0, 1, 0. 9 is, so this is 8, okay? 4, 2, 1, okay? So in binary, see, that's a 9. And in binary, that's 2. So actually, a right parenthesis, okay, if you look at how it's actually stored in a computer as zeros and ones, it's actually 0, 0, 1, 0, 1, 0, 0, 1. Okay? So, you know, if you look at this table here, it's a little hard to interpret. I mean, it's not that straightforward. Right? Okay, so we talked about the ASCII, we talked about the binary number system, and we talked about digital convergence. We talked about what a computer is. Computer literacy refers to a functional understanding of the fundamentals of computers. Computer fluency captures the essence of business expectations. Businesses expect you to be computer fluent. Okay? Bits and bytes. Okay. So a bit is either a 0 or 1, and a byte is 8 bits. Information is actually stored in a computer by bytes. Bits are stored on CDs and DVDs by burning pits in the disk surface. Digitization, also called digitizing, is the process of transforming information, such as text, images, and sound, into digital representation. See, so here's this lady is singing, I guess, or talking. This is her voice signature. Okay? And that's all converted to zeros and ones. Here's ASCII. Basically, ASCII is all the characters on a keyboard. Every time you hit a keyboard entry like a B, that enters 1 byte into the computer. Okay? And here are the zeros and ones here. The binary number system. Digital convergence takes advantage of the fact that digitization standardizes all types of data to zeros and ones to create devices that combine the functionality of several digital electronic devices into one. Okay, computer platforms, personal computers, mobile computing, synchronization, servers, supercomputers, special purpose computers. You know what a PC is. You know what mobile computing is. Synchronization is the process of maintaining common files and data across multiple devices. All I talked about the cloud last time. You remember the cloud? What's cloud computing? I talked about servers last time, supercomputers. Special purpose computers, if you get an MRI or a CAT scan using a special purpose computer. Okay, so that's it for that set of slides, okay? Anybody have any questions about the slide set CO1, digital technology? Okay, then I want to go to the next slide set, hardware. That's CO2. Hardware refers to the tangible parts of computer systems and typically includes support for processing, storage, input, and output. We used to always there was a little standard diagram we always had about the computer hardware. And it went like this. Here was a box called CPU. Here was a box called memory. Here was a box called input. There was a box called output. And then there was another box called storage, okay? And we used to do the storage thing. It looked like a disk, okay? And then we said, well, what happens is when you first start, okay, your computer, and it's running and doing something, you have to input the data from this input unit. And there's different types of input units, right? So there's a keyboard, right? That's the most common input unit. But there's other input units besides keyboard, okay? For instance, the mouse is really an input unit. And you may have other types of input units. You may have a console. If you're playing games, you have different kinds of consoles. And you may have, you know, some kind of sort of tape unit or something else, okay? You may have actually one of these little thumb storage things, right? Or a flash disk. All kinds of input units, okay? And so anyway, to start with, the stuff has to be entered into the computer one way or another, right? And then the computer then will store that in its memory. And so there's this you know, sort of connection between storage and memory. So the CPU, when it receives input, you know, from an input device, can then move that to memory, okay, and get it back, okay. It may store it more permanently on a disk. Ultimately, it then has to, when it gets its answer, it has to write it to an output device here, okay. And an output device can be, you know, a screen, be a printer, and again, there's many different types, you know, of output devices. Now, since memory is really a type of storage, you know, why is it on this little diagram that we normally draw, why do we distinguish between memory and storage? Well, memory is this nowadays, you know, memory is a little chip. You know, if you look inside your computer, you know, you'll have a CPU chip and you'll have a memory chip. Then storage will be like a disk. Now nowadays we have, you know, a solid state storage, okay. But traditionally, the storage was a disk, a hard disk, and it's actually spun around. what was the difference between the memory, this little chip memory, and this disk storage? Well, the difference is the following. This memory is what we call volatile storage. And this disk storage was non-volatile or persistent. Persistent storage, okay? And what that means is when you turn the computer off, all of the volatile memory is lost. And the persistent memory is not lost. So if you're, say, in the middle of running a program and your computer goes down, let's say you turn it off by accident, okay, or the power goes off somehow, all the volatile stuff will be lost. The persistent stuff will still be there. So that means, you know, if you're going to get on your computer and you're going to write a paper, you need to save it, okay? You know, when you say save, what does that do? Save. It puts it on persistent storage, okay? So when you bring up Microsoft Word and you start typing in all this stuff, okay, it's being typed into memory, not into storage, okay? And you can sit there for 30 minutes, an hour, 2 hours, and type stuff in, okay? And then what happens when the power goes off? You just lost 2 hours worth of work. How many have lost work on a computer? How much have you lost? Who's lost something big? How much have you ever lost? Ooh. It wasn't just a 4-page paper though, right? 4-page paper, not too bad. I don't know. But I mean, if you work on a, you know, a big, long paper, and I've known people that get on their computer, you know, and work all day on a paper, all day, and they don't store it, okay? And then they go to lunch and still don't store it, and they come back, you know, and they work on it, and work on it, and work on it, and never store it, okay? Not a good idea, right? Now, actually, most computers will save it for you every now and then, okay? Yeah. So if you've been working on something for a couple of hours and suddenly your computer goes down and you haven't saved it, okay, it may not be lost after all. Okay? When you bring the computer back up, often the operating system will say, your last session was interrupted, okay? Do you want to go back to where you were interrupted, or you want to start all over? And if you say you want to go back to where you interrupted, it may not go back exactly to where it has these checkpoints, maybe. And that's something you can set in the system, okay, the automatic save, okay? But anyway, it's a good idea for you, you know, to save stuff yourself, okay? And so that puts it then on the disk, and then it's still there, right? Now, there's another difference between this memory and this persistent storage. This volatile memory is very fast. That is, moving stuff from the CPU to this memory and back is very fast. Much faster than moving it from the CPU to this storage. Okay? This persistent storage, this disk storage, is sort of slow, really, really slow by comparison to the memory. Okay, so hardware. Hardware refers to the tangible parts of the computer systems and typically includes support for processing, storage, input and output. That'd be the CPU. Okay, what does CPU stand for? The central processing unit. Okay, CPU, central processing unit. On computers nowadays, we also have a GPU. By a computer nowadays, they'll often have a CPU and a GPU. What's a GPU? Graphics processing unit. Right? Okay, so processing carries out the instructions provided by software using specially designed circuitry and a well-defined routine to transform data into useful outputs. Transistor, integrated circuit, central processing unit. What is a transistor? What's a transistor?
Switch.
Yeah, exactly. It's a switch, just like a light switch. You know? What does a transistor look like? Anybody seen a transistor? You actually don't see them too much anymore. Okay? I mean, when I started, in computers, they had vacuum tubes, and a vacuum tube looked like this. I mean, it had a base, and then it had this vacuum tube, and it like a light bulb, okay? And it had these various filaments in it, okay? And so that was a vacuum tube, and vacuum tubes are basically replaced by transistors, okay? A transistor was a little disc of silicon here with 3 little wires sticking out. That was a transistor, okay? And a transistor was a solid state device. And so computers, the very early computers, were built with vacuum tubes. These were very early replaced with transistors, and so computers became solid state. Who invented the transistor? Well, the telephone company invented the transistor. The telephone company, AT&T. Actually, we say the transistor was invented by Bell Labs. And this goes back to like 1947, I think. What's Bell Labs? Bell Labs was the research part of the telephone company. Bell Labs is up in New Jersey. And it's a big research back to the telephone company. AT&T had this big research organization called Bell Labs, and they invented a lot of stuff. And one of the things was the transistor. The transistor was then replaced itself by the integrated circuit. What's the integrated circuit? Well, it was a little chip that had lots of transistors on it. Okay. Nowadays, if you buy, you can get a little processor chip. Okay, your computer has a processor chip, And this processor chip basically has lots of transistors in it. How many transistors is in one of these little processing chips? Many, many, many transistors, okay, are in this processing chip, okay? Thousands of transistors. Multi-thousands of transistors. Who invented the integrated circuit? It was invented in the state of Texas. Did you know that? But it wasn't invented in Houston. It was invented in Dallas. Who invented the transistor? Texas Instruments. Texas Instruments invented the transistor, and TI, and their headquarters in Dallas. Okay, and in fact, the guy who was in charge of it is a guy named Jack Kilby. I mention that because I happen to know Jack Kilby, or I knew Jack Kilby. I worked with him actually for a while. He won the Nobel Prize. Did you know that? He won the Nobel Prize for this. They didn't give him the Nobel Prize until 1995 or something. He's a really old guy when he got the Nobel Prize. I once asked him, I said, Jack, how much money did you get for inventing the integrated circuit? He said, I got $1. $1. I said, that's not very much for such a important invention. He says, well, I was an employee of TI. TI, I had the patent, I had to, I didn't get the patent. He said, in TI, when you made a patent, you got a really important patent. He said, they gave you $1. And he said, they put it in this little frame thing, $1 in a frame thing, and I say on it, say, you can't even spend it. It's in the frame, and it says out your name, what it was for. You hang it on the wall in your office. He said, that $1's still hanging on my wall at my home now. And I said, well, how much money do you think TI got for that patent for the integrated circuit? He said, well, and he said, back in those days, we didn't take intellectual property as seriously as they do now. He said, I don't think TI ever made more than 500 or 600 million. Well, one of the things we want to talk about in this class is intellectual property, And, if you work for a company and you invent something, that intellectual property usually belongs to the company. Usually when you go to work for a company, you have to sign, I think. It's kind of like a premarital, agreement. Anything I invent, belongs to this company. Now, if you work for a university, like I do, they're more liberal, If a professor invents something, the professor gets half, the university gets half. And so, it's much better. How am I doing here? I got 5 more minutes. All right. Okay, transistor, integrated circuit, central processing unit. So here is a transistor, okay? When electricity is flowing through a transistor, it represents a 1. When it is not flowing, it represents a 0. A transistor is an electronic component typically composed of silicon. Everything is silicon. What is silicon anyway? What do you make silicon out of? Where does silicon come from? Sand. You go to the beach, you get some sand. Okay, that's silicon. All these computers are made out of sand. Right? You gotta get some sand, make you a computer. A transistor is an electronic component typically composed of silicon. That's the reason they call it Silicon Valley, right? That opens or closes a circuit to alter the flow of electricity to store and manipulate bits. Okay, so here's the source, okay, the drain, the gate. It's just an on-off switch, okay? Integrated circuit. An integrated circuit connects tiny transistors and other electronics components on a thin piece of semiconductive material such as silicon. So here's the integrated circuit, okay? So this is a chip of one type. Here's all these different chips, okay? And they sit on this motherboard. This motherboard basically just connects everything together. And each one of these little chips has lots of transistors. The central processing unit is a group of circuits that perform the processing in a computer, typically in one integrated circuit called a microprocessor. Most of today's microprocessors contain multiple CPUs or cores. Multi-core processors such as dual-core and quad-core use an architecture that allows the cores to work together for faster processing. Multi-core processors are used in computers other than PCs. Some of the fastest multi-core processors are used in graphics processors, GPUs, powering game consoles. They're also used in servers, supercomputers, and embedded systems. What's an embedded system? An embedded system is something like a thermostat, and it has a computer in it, embedded in it. Okay, you don't know the computer's there. It's like your automobile engine. Okay, it has a computer. Okay, as part of what runs it. You don't realize there's a computer there. Okay. Moore's law states that the number of transistors on a chip will double about every 2 years. There's Moore right there. What do you look like? And here are the years, okay. In 1970, we had about 1,000 or so transistors on a chip. 2010, we have got, whoa, that is a billion transistors on a billion transistors on a chip. Okay, so now I'm out of time, and so I'm going to stop here, and next time I'll start right here. We've still got a lot of this to go here, and I'll be talking about the rest of this next time, and also I'll be talking about the first issue that we have, the I. Yes.
I had a question about the paper. So is the bibliography a part of the 4 pages or is it separate?
Part.
So it's 3 pages of writing and then the bibliography?
If it's a whole page, I expect the references to be only maybe a third of a page.
Okay, so it's just whatever we type up to and then whatever, so it's not its own separate page?
Yeah. That actually had to be 4 pages. Don't worry about it if it goes over a little bit, okay?
Okay.
4 pages is just, more or less what I expect.
So the reference page isn't by itself, it's a part. It's like,
We're very flexible. Okay, we're
Okay.
very flexible. Yes.